In this session, we are going to study another important issue called clustering tendency. What is clustering tendency? That means we want to study whether the data sets we have really contain clusters. That means whether the data contains some inherent grouping structure. Otherwise, even use random generated data, you may find a certain number of clusters. However, it does not really make sense. That means we want to assess whether the data is suitable for clustering. However, to determine the clustering tendency or clusterability is a hard task, just because there are so many definitions of clusters. For example, we studied partitioning methods, hierarchical methods, density-based methods, graph-based methods. All these different methods may have different definitions of clusters. That's why to study whether the data is clusterable or not is pretty hard. However, even we just fix the cluster type, for example, we just study the partitioning methods, it is still hard to define a appropriate NAR model for a data set. However, there are still some studies on clusterability assessment. For example, there are methods like spatial histogram method, distance distribution method, or Hopkins statistic. The general philosophy is they try to compare their measure with the measure generated from random samples to see whether they are rather different. For example, for spatial histogram method, is try to contrast the histogram of the data with the histogram generated from the random sample to see whether they are rather different. Okay. For distance distribution, is try to compare the pairwise point distance from the data and the pairwise distance from the randomly generated samples. Hopkins statistic is to use a sparse sampling test for spatial randomness. And since they carry a quite similar spirit, we will only introduce one, spatial histogram method. For spatial histogram approach, the general philosophy is we try to construct a d-dimensional histogram of the input. For example, this is 2D, we may construct a two-dimensional histogram for the input data set D with the histogram generated from random samples. That means we want to compare the figure generated from the left and that generated from the right figure. Okay. The data is clusterable if these two histogram distributions are rather different. That means they really generate very different distribution, then likely this data set is clusterable. Okay. The concrete method is we try to divide each dimension into equal width bins. Then we try to see each cell here, how many points are in the set. Then we can generate an empirical John probability mass function. Okay. Then for the random generated data sets, we'll do the same. We'll generate empirical John probability mass function. Then what we will do is we try to compare whether these two, they differ quite a lot. That means we want to compare how much they differ. The typical method is we use KR divergence. That means we calculate the KR divergence value. The KR divergence is Kullback-Leibler divergence is defined based on some formulas. I'm not going to introduce the detail of KR divergence. If you want to learn more, you can check any textbook in statistics or machine learning or data mining. In general, they introduce this measure. Then you find if they are very different then from the random samples, then you will say this data set is clusterable. Now we come to the lecture summary. This lecture we discuss clustering validation. Then we introduce basic concept why we want to validate clustering. Especially we discussed one is how to measure the clustering quality. Then we have external measure, and that means we do have ground truth. In that case, we introduce matching-based measure entropy space measures and pairwise measures. Then we also study when we do not have ground truth, we will use some internal measures. And we also study the relative measures. It simply says you have different parameters, you generate different clustering, you want to compare them. Then we also studied cluster stability issue. We studied clustering tendency issue. Okay. Finally, I'm going to introduce a few textbooks, chapters, or journal papers. They discuss the clustering validation measures. Especially what it shows, this one is a summary of many research papers, and Zaki's book gives a lot of details on other measures we did not cover in this lecture. Thank you.